Alright guys, real quick, so today I'm not here, as you can see I'm not going to be in class, so I'm going to show you real quick how to figure some of these out, and most definitely so that you can do the remainder of the lab. Today, remember when you go in, you'll have a warm-up, make sure to do the warm-up, and then you'll get a molecular set from the substitute teacher, and then you'll get going. You'll be separated into all 6 lab tables. And then each of you will be responsible for turning one of these in by the time you leave. Plus, you will also have homework. The homework is online, and I will help you further if you need to with the homework online. I'm not going to make it due till almost Thursday, so don't worry so much about the homework, but I do need you to try it because you will have a quiz the next time I see you, okay? So, the last time we were here, we were talking about the valence shell electron pair repulsion theory, which is nothing much more like I was trying to say is how electron pairs or bonds or lone pairs of electrons situate themselves in 3-dimensional space to create, how do you say, the less energetic or the more energetically favored molecules so that it doesn't require a lot of energy to hold it together. Okay. To a certain point, I guess you can consider it the most stable. So what I'm going to show you real quick, I'm going to show you beryllium chloride. Okay, so here for the name, you see beryllium, and don't forget how to name because it's going to be on your test. You see BE, so you look in the periodic table and you're going to name the first element as is, so it's going to be beryllium. The next element is a chloride. Okay, now because this is actually an ionic compound, okay, but like as I was telling and explaining to you last time, you can get away with just saying beryllium chloride. All right, next one, so we got to do the Lewis structure. So first you have to determine which of these is going to go in the middle, right, the center atom. So the center atom is nothing much more than going to be the one that has the least number of atoms now in binary compounds. Okay, so that means compounds that have 2 elements. So in this case, there's beryllium and chlorine. Chlorine has 2, beryllium has 1. So the one with the least, we're going to use in the middle. So we're going to put beryllium in the middle, right? And we're going to draw the Lewis structure for beryllium, right? And these are the dots that we once did. So we got to look at the, what is it called? The number of valence electrons that beryllium has. And if you look at beryllium, beryllium is situated itself in the second column. So because of that, it has 2 valence electrons. Okay, and we're going to set it as such. Okay, make sure that the molecule is quite symmetrical. All right, so now the next thing we're going to do is we're going to notice that we have 2 chlorines. Well, to do the Lewis structure of chlorine, we're going to put chlorine on both sides of the, well, if my pen will actually work, we'll put chlorine there and chlorine there on both sides of the dots. Now, if you look at chlorine, chlorine is a halogen. It's in the 7th column. That means it's in group 7, so therefore it has 7 valence electrons. Okay. Now, that lonely electron, we're going to put it facing that other lonely electron for beryllium. So we have chlorine, and we're going to put all 7. So chlorine is going to have 3 lone pairs of electrons and 1 single electron. So what we're going to do next is we're going to connect the dots. Right? Now I could have done it a little bit straighter, but I didn't. So if you look at this and you look at the notes that we did, the little cutout kind of thing, you'll notice this does not have lone pairs on the central atom. Because it does not have lone pairs on the central atom, the ball and stick model should be linear. Okay. So this here, you're going to have to actually draw it out. You're going to have to construct it using the molecular set. So make sure you go ahead and do that so you can get an image of what's going on. So how many number of vicinal atoms does it have? So you look at the formula, or even you look at here, you see that this is the center atom, and how many vicinal atoms, how many vecinos? It has 1 and 2. So we're going to put for this one right here, 2. Next, we're going to say the shape and the bond angle. So now here, once you have constructed the molecular set, this will give you more of an image, right? But in any case, since you don't see any lone pairs in the center atom, therefore it has no distortion, right? It is going to be a line. So the shape of this is going to be linear, and the bond angle for a linear molecule is going to be 180.